Hello and good morning, grade 9 with you, Mr. Samir Awad. And today we are going to start lesson 3 of distinguishing among atoms, part 1. And we finished before defining the atoms and the structure of the nuclear atom. And let's start our lesson today. So, how can there be different varieties of atoms? That's like just as there are many types of dogs or atoms come in different varieties too. So atomic number and mass number. What makes one element different from another? That's atomic number. And the atomic number element are different because they contain different numbers of protons. Yeah, an element's atomic number is the number of protons in the nucleus of an atom of the element. And the atomic number identifies the element itself. So if I said atomic number 1, so I will know directly it will be hydrogen. If I said atomic number 2, directly it will be helium. 3, it will be lithium. 4, it will be beryllium. 5, it will be boron. 6, it will be carbon. 7, it will be nitrogen. 8, it will be oxygen. 9, it will be fluorine, and etc. So here guys will get something about the atomic number. So if I say 1 here, it means that I have one proton. And we have to know, guys, that the atom is nuclearly or neutrally when they get the charge positive equal to the charge of negative. The positive charge of the proton is equal to the negative charge of the electrons. So in the neutral atom, I will get the number of protons is equal to the number of electrons. For example, here, if I get to hydrogen, so the number of atomic number will be 1, so the number of protons will be 1, and it's a neutral, so the number of electrons here will be 1 too. On the other side here, well, helium will get the atomic number 2, so the number of protons will be 2, and also the number of electrons will be 2 because the helium is in form of neutral atom. On the other side, let's get 1, get etc., which is oxygen here. We have 8 atomic number, and the protons will be 8, and also on the other side the number of electrons will be 8. But if we get to the mass number that we will get it later, the mass number is equal to the number of protons and neutrons. So you have to add these two cells in order to get mass number. For example, hydrogen here has only one proton but no neutrons, so the mass number will be 1 plus 0, so the mass number for the hydrogen will be 1 too. On the other side, if you get to the helium, you will get that the number of protons is 2 and the number of neutrons is 2. So if I add them together, 2 plus 2 will be 4, so the mass number will be 4. Let's get something is more complicated. For boron here, we'll get 5 protons and 6 neutrons, so the mass number for it will be 11, although the atomic number is 5 because it's the number of protons only. That's it, guys. So atomic number, remember that atoms are electrically neutral, so the number of protons and electrons, the negatively charged electrons and the positively charged protons are equal. Also, the element nitrogen N has atomic number of 7. How many protons and electrons are in the neutral nitrogen atom? So in the neutral nitrogen atom, you will get the atomic number is the number of protons inside, so there will be 7 protons, and also there will be 7 electrons. So identifying the relevant concepts here, the atomic number gives the number of protons, which in the neutral atoms equal to the number of electrons. So if you get to the hydrogen here in order to solve it, we'll get that the atomic number will be 7, so the number of protons will be 7, and also the number of electrons will be the same. The secondly will be mass number, and the total number of protons and neutrons in an atom is called the mass number. So I have to add protons and neutrons inside the nucleus in order to get the mass number. If you know the atomic number of and mass number of the atom, of any atom, you can know of any element too. So you can determine the atom's composition too. The number of neutrons in an atom is difference between the mass number and atomic number. So I have to subtract the atomic number from the mass number in order to get the number of neutrons. So for that, guys, if you want to know the atomic, no, if you have to know the number of neutrons, you have to know first the atomic number and the mass number. And if I subtract the atomic number from the mass number, we will get by the end the number of neutrons, as you can see here. And also mass number, the composition of any atom can be represented in shorthand notation using atomic number and mass number. Like you can see here for gold, guys, yeah, the subscript will be the atomic number and the superscript will be the mass number. And also you will get always the mass number is more than the atomic number. So the number or the atomic number will be subscript and the mass number will be superscript. Yeah, if you don't know what is subscript and superscript, yeah, subscript, it means it will be down. Superscript, it must be up here. So it can also be written as gold 197. If I get that, I said that the gold, so I knew it's 79. And also if I said 197, I'm representing the mass number for the gold. So here, determining the composition of an atom, how many protons, electrons, and neutrons are in each atom. So if I get first of all to the beryllium, yeah, that's the atomic number will be 4, and the number of protons will be 4, 2, and the number of electrons will be 4, 2. But if I want to get the neutrons number, I will subtract the 4 from 9. So 9 minus 4 will be 5, the number of neutrons. On the other side, neon here, we will get that you have the atomic number will be 10. So the number of protons inside the nucleus will be 10. And also the number of electrons, because it's a neutral atom, will be 10. And if I want the number of neutrons, I will subtract 10 from 20. So it will be 20 minus 10 to get the number of neutrons, which is 10 too. So if I get to the sodium or natrium as in Latin, so here I get 11, which is the atomic number, equal to the number of protons, which is equal to the number of electrons, which is equal to 11. And if I want to get the number of neutrons in the sodium atom, so I have to subtract the mass number, the atomic number from the mass number. So it will be 23 minus 11. So the number of neutrons will be 12 in the sodium atom. That's what you will get, guys. Guess what? That is the answer for what we said. On the other side, you can use the atomic number to find the number of protons. Yeah, so the atomic number will always give you the number of protons. And also the atomic number, because the number of protons is equal to the number of electrons in the neutral atom only. So that will give you all of the numbers of the neutrons by the end when you subtract the mass number minus the atomic number, and that's the answer for you. So the results are making sense for us, guys, because it's giving us application for our rules here. What information is needed to determine the composition of a neutral atom of any element? I only have to get atomic number and mass number to get everything about the composition of it: protons, electrons, and neutrons. So that's it. Let's get to the other part, is talking about the isotopes. So isotopes here, it's like you are getting the element twins, yeah, or sometimes more than twins. So if you get the element with its twins, it will be the same identical element, but the difference will be in the mass. Yeah. There are three different kinds of neon atoms. How do these atoms differ? You will see here, guys, that neon here would get 10 protons in each one, which is a specific thing. The atomic number is a specific thing that describes the element, and you know the element name from its atomic number too. On the other side, we'll get the number of neutrons is different, so it's changing the mass number for it. So here it's 10 neutrons, here it's 11, and in the last one it will be 12. So if I get that's neon 20, neon 21, and neon 23, or 22, I'm sorry. So there's no difference between them except for the mass. So I can now describe the isotopes as it is the same element, you know, copies, but they are different in the mass, have the same atomic number, but different in the mass number. So the isotopes are atoms that have the same number of protons, but different number of neutrons, and that's exactly what I said, because the number of protons is the atomic number, but the difference will be according to the number of neutrons, and it will change also the mass number for this one. Because isotopes of an element have different number of neutrons, so they also have different mass number. And despite these differences, isotopes are chemically alike. Why? Because they have identical number of protons and electrons, and that's responsible for the chemical behavior and chemical reaction. So remember, the dogs at the beginning of the lesson, their color or size doesn't change the fact that they are dogs by the end. So similarly, the numbers of the neutrons in the isotopes of an element does not change which element it is, because it's all having the same atomic number, and that's like a fingerprint for all of the elements. So how are the atoms of one element different from the atoms from the other element? That's because of the atomic number. The atomic number is different from an element to another element. The number of protons is different from an element to another element, because that is called the fingerprint, guys. So I can say that the atomic number is a fingerprint. No one has the same fingerprint of the other. On the other side, how are isotopes of the same elements different? They are different according to the number of neutrons, which is exactly the number of mass number. So that is the answer here. You can get it, guys. Yeah, writing chemical symbols of isotopes. And that's easily, if I want to talk about the isotope, I will get it like the element itself. So the atomic number will be subscript and the mass number will be superscript, or I will write only, guys, here, like you can see, carbon dash, and after that dash 12, or carbon dash 13. It means that both are carbon having the same atomic number, but the mass number is different. Here it's 12, and on the other side here it's 13. Identify relevant concepts here. Isotopes are atoms that have the same number of protons but different number of neutrons. The composition of an atom can be expressed by writing chemical symbols with atomic number and the mass number too. So here you can see, guys, that carbon has its atomic number of 6, and the mass number might be 12 or 13, like you can see here. So if I want to write in a symbol, so the symbol will be C for carbon, and 6 will be for the atomic number, and 12 will be the mass number for it. On the other side, the other isotope will be the same atomic number, because they are the same elements and they have the same chemical properties, but the difference here will be in the mass number. It's according to the number of neutrons. So last but not least, guys, why are atoms with different numbers of neutrons still considered to be the same element? Because they have the same atomic number, the same number of protons, which is giving the identity to each element. Thank you guys for listening. Next time we'll start our part 2. Be safe at home. Ask your question through the interactive sessions. And if you please, guys, if you have any question, don't be shy. Goodbye, guys. Study well.